Good morning. Happy April the 9th, 2021 to everybody. And we've got a very lovely astronomy picture of the day this morning. If you think you know what it is, you can be as specific as possible. Go ahead and leave it down in the comments below. All right. If you thought, well, this over here looks like a galaxy, you're correct. Well, maybe you can't see what I'm, I don't think my mouse shows up on the recording. So in the lower right, you see a little galaxy down there, but then there's like a much larger galaxy also, centrally featured one. And again, just a lot of detail in that, like so the fact that you can see sort of like satellite galaxies and even sort of distant things in the background.
Teacher Schleith, excuse the interruption. If you could review the list that Mr. Fry sent out this morning in regards to students who need to do FSA writing makeup testing, send those students to room 13105 at this time. Thank you.
All right, so that wasn't right. Explanation. Close to the Great Bear, Ursa Major, and surrounded by the stars of the hunting dogs, Canis venatici, the celestial wonder was discovered in 1781 by the metric French astronomer Pierre Méchain. Later, it was added to the catalogue of his friend and colleague Charles Messier as M106. Modern deep telescopic views reveal it to be an island universe, a spiral galaxy around 30,000 light years across, located only about 21 million light years beyond the stars of the Milky Way. Along with a bright central core, this stunning galaxy portrait, a composite of image data from amateur and professional telescopes, highlights youthful blue star clusters and reddish stellar nurseries tracing the galaxy's spiral arms. It also shows off remarkable reddish jets of glowing hydrogen gas. In addition to small companion galaxy NGC 4248 at bottom right, background galaxies can be found scattered throughout the frame. M106, also known as NGC 4258, is a nearby example of the Seyfert class of active galaxies seen across the spectrum from radio to X-rays. Active galaxies are powered by matter falling into a massive central black hole. Well, that's exactly what we've been studying this week, right? Quasars. So that's an example of an active galaxy. And I already clicked on this link and it led to an animation, this one, which I think is pretty awesome. So sometimes it's good to, sort of click those links there, especially when it's so relevant to sort of our studies here. So it says near the event horizon. So this would be somehow if we could sort of be in the accretion disk of matter, and you can kind of see where the jets are sort of, ejecting them out like this, and the matter sort of falling in, rubbing into other matter, and then the black hole would be sort of in here. It says, this incredible scientifically accurate animation places the viewer inside the accretion disk of a supermassive black hole. It was created from a supercomputed simulation. How appropriate and relevant to today's essential question also, which is probably the record for the lengthiest essential question so far. Quite light. And it's got like a really long introductory prepositional phrase. And I will read it for the benefit of the YouTube audience that would otherwise just, say, oh no, you left us hanging. What was the essential question? You mentioned it, but didn't read it to us. If Newton's law of universal gravitation allows us to calculate the force of gravity between two massive objects, and Newton's second law of motion allows us to calculate how the force accelerates the mass, how can we calculate how the force of gravity affects more than two objects, like 3 or 4 or trillion or n number of objects? Consider that. We'll see you next time.